Question 28. The curve y equals f of x is shown on the diagram. The equation of the tangent to the curve at point t, negative 1, 6, is y equals x plus 7. At a point R, another tangent parallel to the tangent at t is drawn. The gradient function of the curve is given by dy dx equals 3x squared minus 6x minus 8. Find the coordinates of R. Let's analyze this diagram. We have the graph of what appears to be a cubic function and two tangents drawn parallel to each other. That means they both have the same gradient. Now, the gradient of this tangent here to point T is 1. And because these two tangents are parallel to each other, the gradient of this tangent here is also 1. Now, we're given the gradient function of the curve, so it's already been differentiated for us. And it's 3x squared minus 6x minus 8. And we know that the gradient of the tangent, either tangent, is 1. So we can proceed to find the x-coordinate of point R by solving this equation here, dy dx equals 1. So 3x squared minus 6x minus 8 equals 1. So we have a quadratic equation. Let's clean that up by moving the 1 over to the other side. So we have 3x squared minus 6x minus 9 equals 0. Now it's a non-monic quadratic equation, but we can easily turn it into a monic quadratic equation by dividing all terms by 3. So we get x squared minus 2x minus 3 equals 0. And this is factorizable, easy enough. That's x minus 3 in brackets times x plus 1 in brackets equals 0. So from this expression here, we have these two solutions, x equals negative 1 or x equals 3. Now x equals negative 1 corresponds to the x-coordinate of point T, but we want the x-coordinate of point R. So it's the second solution, 3. Hence the x-coordinate of point R is 3. The next thing we need to find is an expression for f of x, which corresponds to the primitive of the gradient function. So f of x is equal to the integral of the gradient function, 3x squared minus 6x minus 8 dx. So integrating that expression with respect to x, we get f of x is equal to x cubed minus 3x squared minus 8x plus c. And the degree of this polynomial is a 3, which gives rise to a cubic graph. Now we have this plus c, that's the constant of integration. We need to find the value of it. Now what we do know is that the graph of y equals f of x passes through this point here, and that's given in the question, which is the coordinates of point T. So when x equals negative 1, y is equal to 6. Or put another way, f of negative 1 is equal to 6. So if we substitute negative 1 for x and 6 for f of x, we can then solve for the constant of integration c. So negative 1 in brackets cubed minus 3 times negative 1 in brackets squared minus 8 times negative 1 in brackets plus c is equal to 6. And simplifying the left-hand side, we get 4 plus c is equal to 6, hence c is equal to 2. So now we have an expression, or an equation, for the primitive function. In other words, f of x is equal to x cubed minus 3x squared minus 8x plus 2. And that is the equation of this graph here. So now that we have the x-coordinate of point R, which we found here, substituting x equals 3 into the primitive function, or into f of x, we can then find the y-coordinate that corresponds to x equals 3. So f of 3 is equal to 3 cubed minus 3 times 3 squared minus 8 times 3 plus 2, and that equals negative 22. Therefore, the coordinates of point R is 3, negative 22.